Oh yeah. To answer your question, yeah, there's a couple I can give you, and I'll email those out to you. Hold on, let me write that down so I don't forget. I'm also gonna say that so starting the 14th, we're gonna start new material. So it's gonna be a little bit different. Monday, I'll push out some videos on the topic. That goes for pre-algebra and algebra. So I have videos. I'm still gonna do the live streams. Like that's not gonna change. The schedule's just gonna be a little bit different. And the like layout will be a little bit different. And I'll still save the videos and put them up. But how it's gonna go is that Monday you'll get some videos from other resources that kind of talk about the topic they want to go into. Um, and some of the and then like the quote unquote assignments, which I would recommend doing. They're not graded or anything, but I would recommend doing them. Tuesday I will actually do like an actual live lesson on the material, and I'll actually get to delve a little bit more into the topic. Excuse me. And Wednesday I'll probably do more like office hours type of setup where I'll leave it open for like 2 to 3 hours, and we can work through the problems that are in the actual like the quote unquote independent assignment, or if there's IXLs or stuff like that we can go into the topic. And then Thursday I'll probably go into more detail about the lesson, or go more onto something that I wish I could have covered but I wouldn't have been able to cover since this whole thing is going on. But so you will have more stuff. I know you're probably feeling a little antsy, but yeah, I will email you some IXLs that you can do at least to review some more of the algebra stuff other than the stuff that I'm going on in here. Um, I also don't know if you got my email about the law of exponents. I'm going to go over that a little bit more with algebra because I think it'd make more sense if I did it live rather than me just writing it all out, because I wouldn't want your brother to get confused on that. Um, I don't even know if I'm okay. I am. So what I was going to go over today for Math 8 was going to be the simple interest, which is something we went over with consumer math. And then for algebra, I'll go over some law of exponent stuff, and then we can probably just assign those IXLs then too for you. That way it's not, you don't have to go back through your email or any of that stuff, and we can work on some of those. So simple interest. Simple interest is well, I equals capital PRT. I said IPERT, or I equals PERT, or I equals PRT. Was an equation that we went over some time ago. I think it was like January-ish, December-ish time frame. I don't know. It's been a bit, but anyway, I stood for it's interest. Probably spelled that wrong. And two, so that's how much you're either gaining on it, on the money you either invested, or how much you're gonna have to pay back if you borrowed it. P was our, I'm trying to see where I can write this so you can still see that. Principal. Okay, no, I spelled it correctly. The principal, and I did a P, please give me money, please take my money for the investment aspect of it. So it's how much you either invest or borrow. And then we have rate, which is the R. Algebra will be around 130. The rate is a percentage, is what they're going to give you, but you need to use it in decimal form. And then the last thing is time. T is time. And the most important thing about that is that it needs to be in years. Sometimes they may give it to you in months and you have to convert it. And if you have to convert it from months to years, you'll just do months divided by 12 because there's 12 months out of a year. And then it'll be in some type of decimal form, but then it's at least in terms of years. All right, so make sure you can see this. Look at that. That's good. Okay. So I was going to just use an IXL question real quick. Preston has a $40 in his savings account. The interest rate is 5%, which is really high. Normally you won't even have that much on a normal savings account. It's usually pretty small. It's usually like a fraction of a percent. But in this case, I guess he has a really awesome bank that's let him have a high interest rate. So that's 5% per year, and it's not compounded. So if you hear the word not compounded, because there's two types of interest: simple, which is what we learn, and then compound interest, which means that so with compound, after the first year you would have an interest rate, and then on the next year it's not only the interest that you gained from the first year but your original amount. So you're constantly building interest as it's going in, so you're getting more out of that. So you don't have to worry about that this year. But if you hear not compounded, what they mean is that it's simple interest, what we learned, and this is the formula for that. How much will he have in 4 years? Use the formula I equals PRT, where I is the interest earned, P is the principal, so the starting amount, R is the rate, and then as a decimal, which they even tell you here, which is nice, and T is time in years. So Preston had $40 in his savings account, so that's how much that he invested. So that's going to be our P. The interest rate, so R, was 5%, but we want it in decimal form. So to turn that into decimal form, you could either do 5 divided by 100 in your calculator. You could also do, if you're given the handheld, you could just do 5 and then percent, and it will turn it into a decimal. But if you were to divide that, it would be 0.05. There's also the trick where our decimal point's currently right here between the 5 and the percent sign. And if you move it 2 spaces to the left to turn a percent into a decimal, it'd be 0.05. So you could do it that way as well. So we got our rate, and they said time was 4 years. And is it already in terms of years? It is, so we're good. We don't have to divide by 12. Now we're just going to plug it in. So I equals P, so 40. R, so 0.05. And time, which is 4. And if we plug that straight into Desmos, oops, wrong Desmos. And for pre-algebra, algebra can probably attest to this, but it's really important to define your variables. I mean, you're going to have to do it a lot, especially with word problems, so please start getting in the habit of doing that. So if he was to invest this amount of money, how much would he get in interest over those after the 4 years? He would have $8 in interest. So let's go ahead and put that in just to see if we're right. What? 48. Oh, total. That was my fault, y'all, because I didn't read that. How much will he have in 4 years? I was getting in terms of just how much would he have in interest, so they wanted the total afterwards. Here's Mr. Parker already making his first mistake today. So if they ask you for the total afterwards, so this is how much we got in interest. So then how much is it in our total bank account afterwards? So our total would be what our principal originally was plus our interest. So we would have our principal of 40 plus the $8 in interest, so he would have a total of $48 at the end. If they asked just for the interest, which is what my assumption was, I wasn't thinking there, then it would just be 8. But since they were asking for the total, So how much will he have in his account in 4 years? Then that's why it's 48. So again, this one's asking for its total. So how much will he have in 4 years total? I'm just going to erase the what I have for these variables. Just we can just do this a little bit quicker, maybe. All right, so for our principal, how much did he invest? He invested $30 in his savings account. It's probably better if I have a marker. The rate at which he's earning is 10%, and we want to turn that into a decimal, so that as a decimal would be 0.1. Again, you could just do 10 divided by 100, or if you wanted to, you could do the little trick where we just move the decimal place 2 places to the left to turn a percent into a decimal. And then the time is 4 years. And again, it's already in terms of years, so we don't have to divide by 12. So our original equation to plug into, or original, formula is I equals P RT. P is $30. The rate was 10% as a decimal, and then the time was 4 years. So again, if I multiply that into Desmos, I get $12 worth of interest. But they want to know how much is going to be in his account after that amount. So not only will he have the $12 of interest, he's also going to have how much he invested. So his total in his bank account is going to be the amount of interest plus the principal, so how much he originally put in there. So the $12 plus the $30, which means he then is going to have $42 into his account. So that should be our final answer. All right, we'll do one more like that, and then I'll jump up a level. Boop. All right. So Isaac has $60 in savings. I'm using the eraser. I should be using my pen. All right, $60 in savings. So that's how much he invested. He earns 5% interest. Per year, so annually. And the interest is not compounded, so it's simple interest. And then how much will he have in 4 years? The one thing I need to do real quick first is I want to make sure that you can see this. I need to turn the 5% into a decimal. So let's turn that 5% into a decimal. So you could do 5 divided by 100, or you can move it 2 places to the right. If we move, to the left, and if we move it 2 places to the left, 0.05 would be it as a decimal. Alright, and then we're just going to plug it into the equation. So our principal was $60. Our rate as a decimal was 0.05. And the time was 4 years. So with doing that, we're going to use Desmos 60 times 0.05 times 4, and we get $12. So I can write our interest as $12. Now if you want to in Desmos, you can do this a little bit quicker than having to then add them together You can do it all in one go, since they're asking for the interest and, I'm sorry, they're asking for the total. So the total is interest plus the principal. So this is already set up in terms of the principal right now. So I can just at the very end press 60, that was our principal. So 12 plus 60, 72. So he should have $72 in his account after the 4 years. All right, so what I'm going to do is I'm going to jump up a level because again, so this one is just asking for just raise 9 is not compounded to the new. Okay, so this one is asking specifically for interest, so this is one we can do real quick. All right, so principal, how much did he have in his savings account? So how much was he investing? He was investing $80,000. He was gaining an interest rate of 9%. So what is that as a decimal? So if you do 9 divided by 100 into the calculator, you're going to see that's going to be 0.09. You could also move it 2 decimal places to the left. And they're asking how much interest is he going to earn after 2 years. So it is already 2 years. It's already in years, so we're good. And again, they're just asking how much interest. So how much interest will he have? And they want us to round to the nearest cent. So putting in RP is 80,000. I'm going to take out the comma. Our rate is 0.09. And the time was 2 years. So let's find out how much interest that is. And that interest is 80,000 times 0.09 times 2. So he earned $14,400 in interest. Let's put that in. $14,400 in interest. We'll do another one like that, and then we'll jump up a level. All right, so Diego has 60,000 in savings that earns 5% per year. The interest is not compounded, so it's simple interest. And how much will he have? How much will he have in 2 years? So they want to know not how much in interest, but they want to know how much total will he have. So principal is 60K. 5% is the rate, but we have to turn it into a decimal. So 5 divided by 100, or move it 2 spaces to the left, and you get 0.05. And then time is going to be 2 years. And the big thing is how much is he going to have in 2 years? So they want to know the total. So first, let's find the interest. Interest is I equals PRT. Principal was 60,000. rate was 0.05, so 5% as a decimal, and the time was 2 years. So interest, we're going to find out real quick, is that's 6,000, that's 60,000 times 0.05 times to $6,000 in interest. But that's not what they want to know. They want to know the total. So, oh my goodness. Total is going to be your amount of interest plus your principal. So 6,000 plus the original amount, which was 60,000. You add those together, and your total is going to be $66,000 in your account, or in Diego's account. Right, I'm going to jump up a level. All right, awesome. I'm glad that they gave us one finally in months. So this is the one they're going to give us in months. I'm going to do two like this, and then I'm going to actually give you a real world example instead of having these ridiculously high percentages, because you probably won't have like that in the real world. All right. So Charlie has $84,135 in savings. Earns 10% annually. Is not compounded. How much interest will he earn in 8 months? So the amount first, 80 principal. So he has $84,135 in his savings account. He's earning annually at 10%, so 10% as a decimal, 0.1. And then the time is 8 months. So, as I said earlier on, if it's not in years, what you have to do is you're going to take the number of months that tell you. It could be 8, it could be 18, it could be 24, it could be 30, whatever it is, doesn't matter. You're going to take the number of months and you're going to divide it by 12, and it will give you either a, it's going to give you a decimal, maybe an integer, it kind of depends on what the number is, because if it was 24, then it would just be 2, but 8 divided by 12. Very simply, you could simplify this, so 4 goes into 8 twice, 4 goes into 12 3 times, so it's 2/3, so it should be about, it's going to be 0.67 rounded is what that's going to be, but so with something like this, I would probably do 0.667, I guess, if they're going to want us to estimate, but if I'm going to actually put this in the calculator, I'd probably use as many as I can, so I'm going to just write this as 0.66 repeating, and we'll use that number. So principal was 84,135 times 10% as a decimal, 0.1 times 0.66 repeating. What I'm going to do is I'm going to start a new line since I've already divided that, and I'm going to do 84,135 times my rate, 0.1, and then what I can do from using the last number that was up here, I can either type that in, or if you press this answer button, it puts it in for you, and you get an interest of $5,609. Now, the one thing I would stress is here, do not use 0.6 or 0.7, because I will show you real quick what happens. Actually, we'll just do it this way. So you see you have a different amount. These two numbers are very different. You have, so you would want that other $600, correct? And if you did 7, then you would be overestimating how much money you'd be getting. You'd be thinking you're getting close to 6,000 or 5,900 when you're really getting closer to 5,500. So that's why it's always important to use as many of the numbers as you can, because then you'll get as close as you can to what it actually is, or leave it as a fraction. So that's really important to consider when you're using these numbers, because again, like otherwise you'll get the wrong number. I'm going to clear all this, click clear. All right, so they asked only for the amount of interest. So I'm done at this point. I don't need to add, so it's going to be 5,000. Whoops, well, probably need to be in the answer box. 5,609. Submit. Good. We'll do one more, and then I'll give you a real life example with a more, with a, I should say, a lower interest rate. All right. So, principal, how much did they invest? They invested $96,241. They're earning 12% a year, so that is 0.12. And they're asking how much over 9 months. And I'm going to go ahead and put this over 12, so 9 divided by 12 is not going to be an easy number. 3 goes into 9 3 times. 3 goes into 12 4 times if we wanted to simplify, and now we can see that's going to be 0.75 as a decimal. If you didn't want to simplify, you could simply just put 9 divided by 12. Excuse me. 9 divided by 12 in the calculator, and you'd still get a decimal. All right, so we know what we have, and they are looking just for the interest. Okay, so let's just find that. Principal is 96,241. 0.12 times 0.75. So if I multiply all those together, just want to make sure I typed everything okay. Okay, so we get $8,661.69. And they only asked for the amount of interest. And they asked to round to the nearest dollar. So they want us to round to the nearest dollar. So we still have some change right here. So we're looking at 69 cents. We were going to have to round up. That's over 50 cents. So this is going to be about, that means approximately, $8,662. Cool. All right, so I'm going to put that away real quick. I'm going to go back to the Desmos calculator, and I'm going to give you a little bit more real life example. Especially what I'm going to use it for is actually, instead of a savings account with a fraction of a percent, we're going to use a credit card. So you're going to be borrowing money. And then I'll stop there. So at least for today. All right, so so you get a credit card. Typically, they start you with a low amount on your credit card, so they'll usually give you like a $500 limit or a $1,000 limit, and then you can work your way up as you build credit. But let's just say for giggles, we'll just say you max out a credit card and it's at $10,000. So you borrowed $10,000, and this could even be a loan. So you borrow $10,000. But they're going to come at you with a rate of, typically it's going to be in the teens, so to low 20s. So we'll even give it 23.4% interest. So you're borrowing $10,000. They're going to charge you at a rate of 23.4% interest annually. So we're going to turn that into a decimal, 0.234. And you're gonna pay that back over a term of, let's say, you're borrowing it for 6 years. All right, so how much interest are you going to end up paying on this? So after 6 years, you want to know how much interest only. So how much extra you're going to have to pay for borrowing that amount. So you got $10,000 that you're borrowing. They're charging you 23.4%, so that's 0.234 as a decimal, over 6 years. And so how much interest would we have to earn or have to pay back on that? So 10,000 times 0.234 times 6 years, you would end up having to pay well over what you borrowed, so $14,000 and $14,040 extra. That's just the interest. That's not even how much you'd have to pay back total. And typically, most loans are not simple interest. They're actually compound interest, so they throw the interest in on the next rate. On the next year, and you're having to then get a percentage on that. So they continually build. So then total in this case is going to be, you would have to pay them back a total of $10,000 plus your interest of $14,000 and $14,040. So that's going to be $24,040 is what you're going to end up paying back. Especially if you keep that borrowed amount for the full 6 years. If you pay it back now early, there's situations like that where you don't have to worry about as much interest, but that's why it's always important to pay off your credit cards on time. Don't let them build too much interest, because you could end up be paying back more than what you borrowed just in interest. All right, so I'm gonna stop there for today for pre-algebra. Like I said, new stuff is gonna be rolling out for pre-algebra 2 as well on April 14th. And I will give you all more information on that on the first day. So you'll have, and it's gonna be a week by week thing where every week you'll have videos and stuff rolled out. And then I'll still be doing the streaming stuff. And if there's anybody who doesn't have internet or anything, there are going to be resources for them too as well. So don't think that everything has to be online. And we'll see y'all then. I guess in 2 weeks, maybe I might do one stream next week. I'm not sure. I figured with y'all having your actual spring break, you might want to have just the spring break, but I don't know. Y'all let me know. All right, so let's switch over to algebra real quick. And I can also look at the IXL. So quick question that Madison asked about was for some IXLs if you wanted to do them to kind of catch up on anything. The linear inequalities ones are good, so the T's for the most part are really good. Any of the system of equations, if you hadn't finished those, any of those that are the U's, so 1, 2, 4, 5, 8, 9, 10, 11, and 12. They're all, oh no, not 12, not 12. Don't do 12. Someone did 12, and that you don't need to do 12. And I can actually run through a few of those word problem ones because was it this one? I think it was this one. Was giving people a lot of hard time, so a bit of a hard time with it. The 1 through 7 is good. I wouldn't do the add or subtract in scientific notation. I do the multiplying numbers in scientific notation would be good. Don't do division. You don't need to do that. Because I think that's, let me see real quick. Actually, you could do division if you wanted to. Yeah, you could do division if you wanted to do that. And I can type all these up. That's probably what I'll just do. I'll just type up them instead. Okay, so a question was asked though about y is anything to the 0 power 1. So let's do. Okay, so if you have a variable just like x, you can't see that. If you have x, that's going to be x to the 1. It's just itself. Now if you have x to the 0, to better see this, so that the reason that it's 1, so there's two ways we can look at this. If you do x divided by x, right, that gives you 1. Okay, and then knowing the law of exponents, this is x to the 1, this is x to the 1, and what do we do when we divide? We subtract those exponent values. So 1 minus 1 gives us 0. And then there was something else I had. I wish I had written this down instead. Oh, so, and the other way to think about this, there isn't one of these down there at the moment. Like if it's x to the 0, that isn't there. X to the 1 means there's one of those being multiplied of itself. So that's another way to think about it as well. So anything to the 0 power will always be 1. So hopefully that helps your brother out for him figuring out for those exponents to the 0 power. Do you want me to run through those word problems of systems of linear equations? Or nah? Oh, did I do the low? I did, okay. Alright, I'm not hearing anything, nobody opposed to that, so I'll run through some of those. So some of these, if this is the one I remember correctly, nope, that's not the word problem, I pressed the wrong one. Alright, so most of these word problems that were on here were super wordy. You wouldn't have to see anything like that in the future. Alright, so write a system of equations to describe the situation below you, blah, 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 blah. Okay, 2 rental car companies, right? They're running a special this month. So I'm going to call this S rental, A rental, okay, just to make it easier for me. So we have S rental and A rental. So at S rental, customers will pay $38 to rent a mid-size car for the first day, and then $9 for each additional day. So if we were to write that as an equation, so no matter what, that first day is always going to be $38. That's going to be constant. What's going to be dependent on that is how many days are you going to rent it for. So your cost, where can I write this? So to define your variables, you have y and you have x. Y is going to be the cost. How much is it going to cost you? And d will be the number of days. So the cost that it's going to be to you for S rental is going to be, no matter what, $38. That's your constant at $9 a day, so 9x. This would be for S rental. Now what would be for A rental then? If it's $37 for the first day and then $10 for each additional day beyond that. And then they say at some point they're going to be equal. So what day? How many days is it going to take? So, and what's that cost going to be? So for this one, again, your cost is going to be, instead of it being 9x, it's going to be 10x because it's $10 per additional day. And that first day is going to be 37 bucks. All right, so we have our system. Granted, I told y'all if you wanted to use Desmos, use Desmos. They're asking you to solve it by substitution though. So if we wanted to solve this by substitution, what could we do in this case? Well, if I was to write this as you would normally see a system of equations, where the equations are right above each other. Come on now. What would you do for something like this? Well, if you're substituting, you have to solve for a variable. In this case, both equations already solved for a variable. They're both solved for y. Pedro's you go. Can you what? Yeah, I can type those out. That's what I said. I'll type those out because we're just taking. There's more than I can like say there, and that's just too much. Anyway, yeah, I'll type those out as soon as I'm done with this, though. So these are already solved in terms of y, so we can just set them equal to each other. So I'm going to take wherever I see a y, I'm going to put this in. So take this, and I'm going to plug it in for this y. I don't want to plug it into here, because if I plug it into here, then I'm just setting it equal to itself. Oh, before I go. Yeah, I can do that. So rewriting this, I have 9x plus 38. That's a x. I'm sorry for the terrible x. Equals 10x plus 37. And then in this case, we are going to combine our like terms. I would move the 9x over, because otherwise you'll end up with a negative, but that's just me. So subtract 9x on both sides. Cancels. I'm left with 38 on the left, x on the right, plus 37, and then in the same case I want to subtract the constant on the right over. So I can isolate the variable. Well, this came out to be really easy then. So these cancel, you're left with one equals x. So just having an additional day, just one additional day is going to be our x coordinate. So what I am going to do though is I'm going to drag this down just a little bit. So now we have to solve for y. So at this point you can take this x and plug it into either of these two equations and solve for y. You can plug it into the first one, you can plug it into the second one, it doesn't matter, you'll still get the same answer. So I'll just plug it into the first one. We'll play with blue. Y equals 9 times 1 plus 38. 9 times 1 is 9 plus 38 should be 47. And y was our cost, so it's going to cost us $47. So our final answer would be 147. It's the ordered pair. And if we want to check that, y equals 9x plus 38. Y equals 10x plus 37. This case is a little bit far off, so I'm going to back this up. then remember these are our y-intercepts, so we can look for the intersection, and it comes at 147. That's what I got, and that's what they got as well. So then it's going to be for the answer 1x, so 1 additional day, and the customer is going to pay $47 in either of those two situations, so it doesn't matter which one would be the better offer. Okay, so I'm going to erase all of this again. This is their canvas. Probably took away my graphs. It did. It's okay. All right. So write a system of equations solving the substitution to fill in blanks. A pair of kids and a pair of adults decided to compete in a three-legged race. The kids got to start 33 yards ahead of the adults since they had shorter legs. When they were to start, the kids hobbled forward at a rate of 1 yard per second, and the adults hobbled after them at a rate of 44 yards per second. Soon they were side by side. How far did the adults go? How long did that take? So, trying to figure out where I can write this. We got x, we have y. All right, so you have a rate for each one. One was at 1 yard per second. Four is at, I'm sorry, the adults were at 4 yards per second. So if you have a rate, in this case, your bottom number, so the per second is going to be your x. So this is going to be number of seconds or time. And then y is going to be the number of yards, or the distance. So the kids, they're going to go some number of yards, right? And they're going at 1 yard per second, so 1x. And they started, though, a little bit further than the adults. The adults had to gain up some yards, so they were ahead 33. Because they're already at 33 yards, so they're already ahead of the game. The adults are all the way back at the actual starting line, and they're going to go, so they're at point 0. And if you were to visualize this, so this is like, here's the starting line. They're running this way. See, the adults are having to run. And then like 33 yards ahead of them is where the kids are starting. So the kids have already made that 33-yard jump. And they're going at a rate of 4x. So 4 yards per second. And at some point they meet up. They cross each other's paths. So they want to know where that is for substitution. We can solve that. Again, both of these equations are already solved for y. We don't have to solve for any of the variables. So we can then just set them equal to each other. Am I going too fast for y'all? Also, I just want to make sure I'm not moving too fast. Or if there's other stuff you want to go over, I can stop this as well. So I'm going to move the 1x over to combine my like terms. Cancels. I'm left with 33 equals 3x. Divide by 3. Divide by 3. So x equals 11. So in 11 seconds, they're going to meet up. Okay, so the adults caught up to the kids in about 11 seconds. Because I remember we labeled our variables over here. Now that we know the time, and we know the first portion of our coordinate, our x and our y coordinate, so we know our x is going to be 11. Now we have to find the distance. And again, you can put it in either one of these. Probably just going to be easiest to put it here because you don't have to worry about the coefficient. It's just, I mean, constant. It's just a one-step equation. You don't have to worry about adding. So I'm going to move this down just a little bit. And I'm going to use y equals 4x. So y equals 4x. Plug in 11 for x, so y equals 4 times 11. So that means that they caught up to them in 11 seconds, and that was at 44 yards. So now we have our y coordinate as well. So they caught up to them at the 44-yard mark, and they did it in 11 seconds. And if you wanted to plug that into Desmos, y equals 4x for the adults, and kids was 1x plus 33. 1144, that's what I got. That's what they got as well. Just to double check. Boom. Oh, this only has one level. Okay. Yeah, we can do this one. Okay. I was just reading it to see if this is a good one to work with. Alright, so they want us to write a substitution. Video rental company offers a plan that includes a membership of $6 and then charges $2 for every DVD borrowed. So let's call this, we're gonna call the first one Blockbuster. And the other one's Netflix, we'll call that Net. So Blockbuster allows you to have a plan that is $6 no matter what. So Y is going to be your your cost, and X will be the number of DVDs. So Y is going to be, for this case, is going to be Y equals 6 is a constant no matter what, and then it's $2 for every DVD borrowed, so that's going to be 2x plus the $6 constant for the fee. That's going to be it for this block company, and then for the net company, you're going to have a constant rate of just $14 per month, no matter what, and you don't get charged for it because you're going to get an unlimited amount of DVDs, so it's just $14 flat. So they want to know how many DVDs do you have to borrow from this first company in order to make it worth it, like to make which one of these to be about the same. So when would they be exactly even? So to do that, you're just going to substitute in. So anytime you see a y, you can plug either in the 2x plus 6 into this equation, or you can put in the 14 in for the y for over here. And I'm probably going to just do that. So I'm just going to bring the 14 over here. So you'll get 14 equals 2x plus 6. I'm going to subtract 6 from both sides. Cancels. 14 minus 6 is 8. So if you borrowed 4 DVDs, then the rate would be the same. You'd be saving money if you rented less, but if you rented more than that, this would be the better deal. But in this case, if you rented four DVDs, then the equations would be even. And how much would that cost you? And you already know at this point because they told you flat out y equals 14. So then it's going to be a 4 DVDs. So 414 is where they should cross. So that's 4 DVDs. I don't know why to give that a capital S. And just to show you, so So right here, 414. And at this point, then the cost is going to be much more over here. Now, if you rented less, then it's better to use plan A than plan B. But if you used the second option, the Netflix, then it'd be better just to stick with them if you rented more movies, DVDs. Clear canvas. Kind of want to do an elimination one. I'm going to switch to elimination, y'all. I hope that's okay. They want you to write describe the situation above. Band students at Rockport High School sell candy every year as a fundraiser. Last year, they sold 78 boxes of truffles and 43 boxes of peanut brittle, raising a total amount of $421. This year, they sold 72 boxes of truffles and 43 boxes of peanut brittle. They raised $409. How much does each band earn from each item? So how much is the cost for each item? So it's going to be easy for us to set up in this one. So X would be, what's the first one they give us? Truffles. Well, that's going to be truffles. True. So TRU stands for truffles, and then Y is going to be the amount of peanut brittle, so that's going to be PB, peanut brittle. So in the first year, or the last year, I'm sorry, they had 78 boxes of truffles, so 78X, and 53 boxes of peanut brittle to get you all $421. In this following year, they had 72 boxes of truffles and 53 boxes of peanut brittle again to get us an amount of $409. So remember with elimination, if your coefficients are the same, we're good, but you want the signs to be different, they're not. If they're not, then you're going to subtract. And honestly, subtracting is the same thing as if we were to multiply this whole thing by -1, because technically then we would be changing the coefficients to match up, and then we could add. So that's another option too, which is where you could multiply this whole bottom equation by -1, and then just add them together. But it's the same process. So subtract. 78 minus 72 is going to be 6x. 53 minus 53 is going to be 0. 421 minus 409 is going to be 12. Then we're just going to divide 6 on both sides. So x equals 2. So you and to be more specific, it's $2 per box of truffles. I'm just going to leave this true. Now, at this point, you can plug this x into either one and then solve for the y. I'm going to put it in, I'll just put it in the first one, I don't care. Um, 78 times 2, so 8 times 2 is 16, carry the 1, 2 times 7 is 14, plus the 1, so that's 156. Subtract the 156 on both sides. So this cancels. Just so you can see this a little bit better, just scroll this down some. So, oh my goodness. So you're left with 53y. I'm just going to put this in the calculator at this point just to make it a little bit quicker, because otherwise I'm wasting y'all's time. So 265. And then divide by 53. So then for the box of peanut brittle, it's going to be $5 per box of peanut brittle. So let's plug those bad boys in. So $2 for this and $5 for this. Alright, I'm gonna do another one if y'all are okay with that. And if not, it's okay. Y'all can leave if you need to. But I'm gonna do at least another one. And then I can give you all those Excels if you want to do them. You don't have to. I mean, it's just something if you want like to review some stuff while you're waiting for the 14th to kick out the new stuff. So, all right. High school science department is purchasing new earth science and physics textbooks. So, physics and earth science textbooks. We'll make physics X, earth science Y in this case. So Miss Underwood has requested 70 earth science textbooks and 84 physics textbooks for all of her classes, which is going to cost the department $8,092. And then Mr. Vega has asked for 81 earth science textbooks and 81 physics textbooks. And that is going to cost $8,424. That was a lot of numbers to look at. Okay, just want to make sure I got this all right. So 70 earth science, 70 Y, 84 physics, 84 X, 8092, 81, 81, YX, YX, and 8424. Okay, so none of the coefficients match up, so we're going to have to find common factors in between both. So you can do one of two things. Let's see. Either of these are a factor of 9, so we wouldn't be able to do that. But they could probably... let's see. Let's do 81 times 4 real quick and see. That's 324. And can we do... No. Bless you. Boom. Okay, that took a lot longer than I wanted to. Alright, sorry y'all. So, it was probably an easier way to do that right now, but I'm not thinking 100% on myself, so if I multiply 81 by 28, and I multiply this top number, so I want to get 84 to match up, so I'm going to multiply it by 27. So let's do that real quick. So I already know what these numbers are going to be, so I'll make those new numbers. So for the top number, for the 84, it's going to be 2,268x, and for the bottom number, it's going to be same thing, 2,268x, 70 times 27 is 1890. And for the bottom number, it's just going to be the same thing, so 2,268y, 824. Oh my goodness. Alright, so now that I have that set up, honestly, another way that you could have done this, and I know this is kind of ridiculous for how I did this, and this other way to do it you could have done as well, it'd just be in massively large numbers, is that you could also probably divide or multiply these each by the same number. So if you multiplied this whole thing by 81 and multiplied this whole thing by 84, then you know these two factors would match up. It would just be massive numbers. But again, that's another way to do that if you didn't want to do it the way that I did it, to run through like that. So now that we have them where they're equal, I can subtract the bottom. I'm gonna have to scroll this up just at least for me. I know y'all can probably still see it, but my screen's a little bit smaller. Alright, 1890 minus 2,268. So we had negative 3. Negative 378y. These cancel. So that's equal to 21. Oh my goodness. 21,844 minus 235, 72. Negative 17,388. So now I just need to divide on both sides. Divide by negative 378 on both sides. So the number of y was earth science. Yeah, y was earth science. So the number of earth science books is gonna be $46 per textbook. So we found the first number. Now we have to go and find out how much it's going to cost then for the physics textbook. Again, we can put this 46 in either into the first equation or the second equation. It doesn't matter. Do not use these large numbers down here. What was it beforehand? So either use the 70y plus 84x or the 81y plus 81x. I'll use the second equation this time since I keep using the first one, and plug those in. So 81 times 46 is 81x was 8,424. 81 times 46 is This would be 3,726. So subtract on both sides. So we get 4,698. And the last step we have to do then is just isolate x by dividing 81 on both sides. So the cost per physics textbook is $58 per physics textbook. So if you had your variables mixed up, like if you had the physics was your y and the earth science is your x, that's fine as well, as long as you label them appropriately, because now we can put these in. So earth science was 46, and physics was 58. I know that was a little bit of a lengthy problem. Boom. Okay. Alright, so if you would like some IXLs, let me do this. Let me clear this bad boy off. Okay. Alright, I'm just going row or column by column, so if I stop, I'm sorry. You're good. That should be good. Yeah, because we are going to have to start using algebra tiles again. Okay, so if you want some extra practice, here's J1. J6, I mean, most of these you might have already done already. I could give you some algebra too, though, because you're going to have to do this stuff. I mean, you might not use IXL next year, so that's another thing too, if you wanted to use it. And I can't see the chat right now, so if you're saying, yeah, you want me to assign some algebra too, give me a second, because I can't see it right now. You don't need to know matrices this year. Q10. Q9 too. If you haven't done these already, the R's are good because I know the direct and inverse has given some people some problems. So R 4 through 8. I'm sorry this is taking me a bit. I'm just trying to see if looking at the skill levels too. I mean, y'all can see this on my screen as well, so you know. Okay, I'm gonna tell you T1, but it's best if you put T1 into Desmos. So I'm gonna say T1, but I would say use Desmos, use Desmos. However, you can substitute it in, and that will, you can still solve it that way, but this will, using Desmos will help. Should be able to do that, that should be fine. T, I don't like that. No, I already know those are bad. T3, 5, 6. 3, 5, and 6. Honestly, I mean, I could give you the exponent ones too, but alright, I mean, if you want, I mean, basically all I'm doing is just giving you a list of what we've already done. With exponents with decimals and fractional things? No. One, 3, 4. Should have just done the 3 through 6, but whatever. Oh, and 7, I didn't see that. 3 through 7. This is the stuff we were doing at the end though, so that's why I would suggest the you can't do those yet. Where are the cube roots? I wish there were cubes, but I guess there's not going to be any cubes for that, but we can at least do those. EE. Make us C in the other one though, or P. 1, 2, 4, and 5. Yeah, you're correct. There's no SOLs this year. But I'm still trying to get y'all prepared for Algebra 2. That's why I'm still going to do the streams. Because I want you to at least still have that live feedback when you can. I just feel bad for kids who don't have the internet, so if you can, I can try to send it out via like Remind or something, but sometimes like even with that, it's still data that they have to download. So if there's any way that you can get it to the kids that don't have it, I'd appreciate that too. But anyway, so those are some IXLs. I can look into Algebra 2 if you'd like. In fact, I'm going to go ahead and look at that while I'm waiting to see if you would like that or not, because I'm still going to look. Exponential and log functions, those are going to be fun. Oh, circles and ellipses though, those were awful. At least for me. Especially when you get into calculus. Trig functions. Oof. Why do I have to like make it so massive for me to like have to get it? I'll do that yet. Dang, they don't even have that in here either. What? That's amazing. Oh heck, let me see if there's any Indy, Lola. Lola. Where, baby girl?
Hey, girls, come on, come here.
I guess they don't have any of that. Alright, I'm gonna make this smaller so I can finally see. I'm kind of surprised they don't have that though. Whatever. Hey Timothy. So yeah, I can do more problems though, if that's what y'all want. I said it only for the half hour because I didn't want to burn y'all out with stuff, but I got more I can do. Because right now, the next thing I gotta get some stuff ready for y'all for the 14th rollout for new material or extended material, wherever they want it, how they want that said. Madison, did you at least get those IXLs, or do you still want me to email them? Alright, well, I'm gonna email you just in case because I don't know if you got them or not. So hold on 1 second, then I can start going back to stuff if y'all have questions still. Oh. Okay. Do y'all want me to go through any more questions, or y'all kind of just done? Sorry, I had to send that email just real quick, so I make sure that Madison grabbed those IXLs. Bye. Have a good one. If there's no more questions, I'll stop there. I miss y'all a lot. Um, but I'm here if y'all need anything. So if you want to email me any other questions, if you want me to stream over spring break, I will gladly do that with y'all. Just kind of let me know, because as of right now, I'll plan not to unless I hear from anybody that wants the stream. And like I said, you can do for algebra, you can do some of those IXLs if you want to do that. They're mainly just ones I've already assigned or I used as extra credit. You do not have SOLs this year as of right now. There's like so how it's going is that there's like a waiver that the governor and the VDOE needs to fill out. I'm not sure of all the 100% of the detail situations, but as of right now, that waiver is going into place. So I would not plan for any SOLs currently right now. But still, if you could please, I mean, there's going to be material being run out for all the subjects. I know for me, I was going to start materials this week, but they wanted us to wait until after spring break. So new materials going to start out for all the classes starting the 14th of April. I don't know how it is for the other classes. I know like they're going to be teaching certain concepts, but I know at least for me how I'm planning to do mine. I mean, if you care, it doesn't matter. You'll find out later either way. But I'm gonna push out like what's called like in I guess the business world like a soft push out, so like a soft rollout, so quiet, so it's not very. I'm not doing anything on that first Monday. The Monday that it comes out is just the material. I'll give you videos to assist with stuff. You don't have to do the notes yet, so you can at least look at the stuff on Monday. That would be my suggestion. If you want to watch those extra videos, that's good too. It's not going to be videos of me. It's going to be other videos that I find that is relevant to the resources that I was going to go over. I'm still going to do a lesson on Tuesday and Thursday with the live streams, and then I'll save them and post them up. So if you can't make the times, that's fine. Time right now, I'm not 100% sure when I'm going to put that. It might be in the morning, it might be in the afternoon. But again, I'll have a schedule set in place at least by the end of next week, definitely for that. So Tuesdays and Thursdays will be like live stream lessons. Wednesdays is going to be a little bit different. I still will live stream, but it's going to be to go over questions on any of like the independent assignments, the IXLs. If I give you something in Khan Academy, it's tough to go over that. So there's still time to ask questions as well, not only during the two live lessons, but also during that Wednesday as well. And then I'll probably do one for Friday as well, but I need to see if I can get all this stuff done before we have to push everything out. Then I will probably do one on Friday as well. So we'll do 4 days of, so 2 days of live stream lessons and then 2 days of questions. Basically like what's called office hours when y'all have that type of situation. So you can ask questions then. And then I can go over anything else that y'all might have questions on too. I can help with most of the subjects with the best I can. So if you have questions on like physics stuff, I can help with that. We can even go in and learn other stuff too as we're doing it. Like let's say you have a question in science, I can see what y'all are working on that. And we can go through problems that way as well. But just let me know. I'm here to help as much as I can when I can. So we still have 7 awesome weeks together, even though it's digital. And we'll make it work. Did that answer your question? Hopefully that answered your question. I'm not sure if it did or didn't. I didn't. Oh wait, now someone's texting. Huh. You too, bud. Miss ya. Hope y'all doing well. I'll go ahead and close out the stream, but I will see y'all. I guess just email me or put something in Google Classroom if you'd like me to at least stream at least once or twice next week. I wasn't planning to because that's y'all's spring break, but um, again, be prepared. New stuff's starting up right after spring, y'all's quote unquote spring break. All right, have a good afternoon.